Hello, this is Yashveen. In this video, I'll be solving paper 4, variant 3, October, November 2018 as 0620 chemistry. Starting with question number 1, answer the following questions using only the substances in the list. Each substance may be used once, more than once, or not at all. State to which substance is an element. So we have oxygen over here, and ore of iron, which is hematite. C used to bleach wood pulp. So we have sulfur dioxide over here. And then used to manufacture fertilizers, which is ammonia. E, a toxic gas produced during the incomplete combustion of hydrocarbons, which is carbon monoxide. F, an ionic compound, which would be sodium chloride. E, a reactant in photosynthesis, which is carbon dioxide. And finally, a product of photosynthesis, which is oxygen. 2. This question is about electrolysis. A1. What is meant by the term electrolysis? So you write down the definition and so that it has 2 points covering the 2 marks, which would be to name the product of the particle responsible for the conduction of electricity during the electrolysis in the metal wires. So we have electrons flowing through the metal wires in the electrolyte during electrolysis. And in the electrolyte itself, we have the ions carrying charges. B, the table gives information about products of electrolysis of 2 electrolytes. Platinum electrodes are used in each case, and give 2 reasons why platinum is used as an electrode. So you want to use something which not only conducts electricity but is also inert, and those are the 2 properties which platinum has. To complete the table, so we have the first electrolyte as concentrated aqueous sodium chloride. So it suggests you write down the ions that are going to form in this electrolyte. Okay, so first off, since this is a solution, concentrated solution, we'd have the ions of water, the hydrogen and hydroxide ion from water, and then the compound itself, which gives potassium and chloride ions. So hydrogen and potassium ions are the positive ions, and then chloride and hydroxide ions are the negative ions. Since anode is the positive electrode, it attracts the negative ions, which are hydroxide and chloride. And since chloride is the more reactive of the two, chlorine would get discharged at anode. And since it's chlorine, it would form green bubbles. Name of the product at the anode. So this is chlorine. And then the observation at cathode. So we have the positive ions are hydrogen and potassium. So in case of the positive ions, it's completely opposite. The more reactive of the two, in this case is potassium, stays behind as the ion itself. Hydrogen ions are attracted towards the cathode, and so hydrogen forms at this electrode. Alright, and then we have aqueous copper sulfate. Let me write down the ions once again. Since it's aqueous, we'd have hydrogen and hydroxide ions, and then the compound itself, which would give copper and sulfate ions. Name of the product at anode, so we have the negative ions as hydroxide and sulfate ions, and as discussed earlier, the more reactive of the two negative ions reaches the anode, and so in this case it is the hydroxide ion which is more reactive than sulfate ion, and that would give oxygen gas. Then the cathode would attract the positive ions, and since the more reactive of the two remains behind, that would be hydrogen, which is more reactive than copper. So copper is deposited at the negative electrode, so you'd see a brown solid forming at cathode. Name of the product would be copper, of course. 3-tin is a metallic element in group 4. Its main ore is cassiterite, which is an impure form of tin oxide. Tin also occurs in stenite. So calculate the relative formula mass of copper. Alright, calculate the relative formula mass of stenite. Okay, so you multiply the relative atomic mass of each element with the number of electrons of the element in this compound. So starting with copper, we have 2 atoms of copper, and then its atomic mass, which is 64, and then we add the rest of the masses. So iron is 56, tin is 119, and then we have 4 atoms of sulfur, so we multiply 4 with 32, and this gives the relative formula mass as 431. The relative formula mass of tin oxide is 151. Calculate the percentage of tin by mass in tin oxide. Okay, so you divide the atomic mass of tin with the molecular mass or the formula mass of the compound, and then multiply it by 100. That would be 119 over 151, and multiply the answer with 100, which gives the answer as 78.8%. The percentage of tin by mass in stenite. The percentage of tin by mass in stenite is 27.6, which is less than the percentage in tin oxide. Use this information and your answer to B to suggest whether it would be better to extract tin from tin oxide or stenite, and explain your answer. So of course tin oxide would be better, would be a better source, as it has a greater percentage composition of tin than stenite. D. Tin can be extracted by heating tin oxide with carbon. Carbon monoxide is the other product. Write a chemical equation for the reaction. Alright, so you have tin oxide which reacts with carbon. So carbon in this case is more reactive than tin, so it can displace it, and this forms tin as well as carbon monoxide. And now you need to balance the equation. So you have 2 of oxygens on the left hand side, balancing it over here, and with the carbon atoms also. E. The position of tin in the reactivity series is shown. So tin is more reactive than copper but less reactive than iron. A student added iron to a solution containing tin ions. That means the solution initially had a compound of tin dissolved in it, which released tin ions. The student then separately added tin to a solution containing copper ions. It would be the same case with this one as well. Complete the ionic equations. If there is no reaction, write no reaction. So as you can see over here, iron is more reactive than tin, so it would displace tin from its compound and form an iron itself or get oxidized, and also leave tin reduced, which would form the tin metal itself from the iron. So we have the iron over here and the tin metal. Similarly, tin here would displace copper from its compound, as copper is less reactive than tin. So tin now forms an ion, gets oxidized using electrons, and copper gets reduced, gaining electron to form copper metal. F. Copper nitrate decomposes when it is heated. The only solid product is copper oxide. There are two gaseous products. One of the gaseous products is oxygen. One, describe a test for oxygen. So the test is a glowing splint which relights in the presence of oxygen. To name the other gaseous product and describe its appearance. So the other gaseous product is nitrogen dioxide, and it is a brown colored gas. Three, write a chemical equation for the thermal decomposition of copper nitrate. Alright, so you just have copper nitrate, and since copper has a charge of 2+, I'm going to put brackets around the nitrate ion. And then we have copper oxide, nitrogen dioxide, as well as oxygen. And you need to balance the number of atoms on both sides. Iron does not rust when it is completely coated with zinc. When the zinc is scratched, the iron still does not rust. 1. Explain why the iron does not rust when it is completely coated with zinc. So zinc acts as a barrier, prevents contact between iron with oxygen and water, which would have formed rust. To explain why iron still does not rust when the zinc is scratched. So since zinc is more reactive than iron, it would lose electrons or get oxidized, and as a result of this, iron won't be able to react with oxygen or get oxidized, and so it would not corrode or wouldn't form rust. For dilute sulfuric acid and aqueous potassium hydroxide can be used to make potassium sulfate crystals using a method that includes titration. So you have a burette filled with dilute sulfuric acid and a conical flask containing a certain volume of potassium hydroxide. A student titrated 25 cm cube of 0.05 mole per dm cube aqueous potassium hydroxide with dilute sulfuric acid in the presence of an indicator. So this indicator would turn the color of neutral as soon as all of the potassium hydroxide is neutralized by the dilute sulfuric acid dripping down the burette. And it would initially be the color that represents basic pH due to the potassium hydroxide. The volume of dilute sulfuric acid needed to neutralize aqueous potassium hydroxide was 20 cm cube. So you're given the volume and concentration of the base and the volume of acid. The equation for the reaction is shown, and you're asked to determine the concentration of dilute sulfuric acid. So first you need to follow out the steps which would lead you to the answer eventually. Calculate the number of moles of aqueous potassium hydroxide. So you have the concentration and volume. You can use the formula moles is equal to concentration into volume, But for that, you need to have both of the concentration and volume in the same units. And I'm going to convert the volume from centimeter cube to dm cube. That would mean I'd have to divide 25 by 1000 and then multiply it with 0.05. So 0.05 multiplied by the volume in dm cube. That would give the number of moles as 1.25. Okay. Calculate the second part requires you to calculate the number of moles of dilute sulfuric acid needed to neutralize the aqueous potassium hydroxide. So the question only gives you the volume of acid, which is not enough to calculate the number of moles from the value. You can, however, use the value of moles calculated for potassium hydroxide to deduce the number of moles of the acid using the equation. So the ratio in the equation states that for every 2 moles of potassium hydroxide, you need 1 mole of sulfuric acid, that is half of the moles of acid for each 1 mole, for every 1 mole of the base, the alkali. And that means you can divide this value, which is 1.25 into 10 to the power of negative 3 with 2, which would give you the value of moles of sulfuric acid. So once you divide this with 2, you'd get the answer as 6.25 into 10 to the power of negative 4. And then calculate the concentration of dilute sulfuric acid. So you have the number of moles, the volume as well. And so now you need to calculate the concentration, which would be number of moles divided by volume. And the volume was given in the question in centimeter cube, so you need to convert that into dm cube. So you have 6.25 into 10 to the power of negative 4 multiplied by 1000 over 20. This just converts the volume from centimeter cube to dm cube, and the final answer is 0.03125 mole per dm cube. B. After the titration has completed, the conical flask contains an aqueous solution of potassium sulfate, which is the salt formed from the neutral titration, and some of the dissolved indicator. Describe how to prepare a pure dry sample of potassium sulfate crystals from new solutions of dilute sulfuric acid and aqueous potassium hydroxide of the same concentrations as used in the titration. Include a series of key steps in your answer. Alright, so the initial step, you had the indicator and some excess of the reagents left after titration was completed, and so now you don't want that. You do, however, have the amounts, the volumes, and the concentration of both the acid and the base needed for complete neutralization. So now that you have the moles required for complete neutralization of acid and the alkali, you can use them without using the indicator, and you'd carry out the same process. So you repeat the process and without using any indicator, because now you know the exact amount needed for complete neutralization. So we already had a measured volume of alkali, the potassium hydroxide, and after titration the volume of acid was also known. And now you heat it so that crystals can form. You heat it until the crystallization point and not more than that, And then you allow it to cool down so that all of the crystals would be able to form. And in the last step, you wash the crystals and then carefully dry them using filter papers. See, potassium hydrogen sulfate is an acid salt. It dissolves in water to produce aqueous solution. X containing potassium, hydrogen, and sulfate ions. Describe what you'd see when the following experiments are done. So the first one is magnesium ribbon added to an aqueous solution of X. Since this salt is an acid, its solution would also act like an acid. So that means the reaction would be similar to what would happen if you added magnesium to an acid, as it also contains hydrogen ions. So magnesium would dissolve and hydrogen would form, and you're supposed to describe what you see or the observations. So magnesium dissolves and you'd see effervescence. 2. A flame test is done on solution X. So the flame test would be for the potassium ions. So it would give a lilac colored flame. 3. An aqueous solution containing barium ions is added to solution X. So barium would react with the sulfate ion and it would form barium sulfate, which is insoluble. So that would mean a precipitate which would be white in color. D. Dilute sulfuric acid reacts with bases, metals, and carbonates. Write chemical equations for the reaction of dilute sulfuric acid with each of the following. Okay, so first off you have magnesium hydroxide with the acid. So here this forms the salt magnesium sulfate and water. Balancing the equation, you have 2 molecules of water. Then we have a zinc reacting with acid. So this would form zinc sulfate and hydrogen. And then finally you have a carbonate. This would form a salt, carbon dioxide, and water, starting with the salt, which would be sodium sulfate. Okay, so the formula of sodium sulfate. Sodium has a charge of +1. You can write valency or charge, doesn't really matter. We care about are the numbers over here, and sulfate ion has a charge of -2. So you cross these numbers and then you'd have 2 atoms of sodium and a single sulfate ion in every sodium sulfate molecule. So this is how you form the formula, and a sodium carbonate would be formed using the same method. 5. A student investigates the rate of reaction between lumps of calcium carbonate and dilute hydrochloric acid using the apparatus shown. So calcium carbonate was in excess. That means dilute hydrochloric acid has to be the limiting reagent. A. Which measurements should the student make during the reaction to determine the rate of reaction? So you either have to take, alright, so here you need to take the volume of gas, which is carbon dioxide in this case, that is produced by the reaction, and the time taken for the gas to form. B. What happens to the rate of reaction as the reaction proceeds? Explain your answer. Alright, so as the reaction proceeds, dilute hydrochloric acid, which is the limiting reagent, would decrease in concentration which would in turn affect the rate of reaction. So rate decreases. And here you have to mention the limiting reagent, diluted hydrochloric acid, since calcium carbonate is in excess. And because concentration decreases, the collision between calcium carbonate and hydrochloric acid would also decrease, which is the reason that the rate decreases. The student repeated the experiment at a higher temperature. All other conditions were kept the same. The student found that the rate of reaction increased. Explain in terms of collision why the rate of reaction increased. So kinetic energy is proportional to temperature. That means when temperature increases, kinetic energy also increases, which means molecules move faster. And as a result of this, they collide at a higher speed or a higher rate. So these are the 3 points. And then the last point is that an increase in temperature means a greater proportion of molecules or reactant particles has energy that is more than the activation energy, and because any molecules having energy that is less than the activation energy would not be able to react even if they collide with because the energy won't be enough. Apart from using a higher temperature, suggest two other methods of increasing this reaction. So you can either increase the surface area or uh, increase the concentration of the acid. Surface area of the lumps of calcium carbonate. By breaking it down into smaller pieces, and similarly you can also increase the concentration. One ethanol can be manufactured by fermentation and hydration. One, describe these two processes of ethanol mixture. In each case, you should identify the reactants, give the reaction conditions, and write a chemical equation for the reaction which produces ethanol. So this question is of 6 marks. You need to write 3 points for each of the two processes to gain all of the 6 marks. The first one is fermentation, which only requires glucose as the reactant, and the reaction conditions, or you need yeast for fermentation, and finally the equation. So you have C6H12 and O6, which ferments in the presence of yeast, and this forms ethanol. As well as carbon dioxide, and then finally balance the equation. And then you have hydration of ethene. Okay, so you need ethene as well, and so you need ethene and steam over here as the reactants, and the conditions are the temperature, pressure, and catalyst. You can write any of the one because you only need 3 marks for each. You don't need to write all of the details. So I'll write the pressure, which is 60 atmospheres. You can write the temperature, which is 300 degrees Celsius. And then finally the equation. So you have ethene and steam. C2H4 plus H2O, which would give C2H5OH. To give two advantages of ethanol mixture, of ethanol manufacture by fermentation compared to hydration. So it would be you'd use the resource as the source that you'd use would be glucose, which is a renewable resource, and it would also require a much lower temperature, and therefore it would reduce the costs. Two major uses of ethanol. So it's used as a solvent and fuel. B. The structures of some polymers are shown. Answer the following questions about these polymers. Each polymer may be used once more than once or not at all. Alright, the first part is an addition polymer. So an addition polymer is made up of the same repeating monomer. And in this case, it's E over here. A protein. So here you need a structure with an amide link, which is this one, D. This is the amide link of carbon double bonded to oxygen and also bonded to nitrogen, which is bonded to a hydrogen atom. A polyester made from only one monomer. Alright, so a polyester would have an ester link, so which is this link over here, carbon double bonded to oxygen and another oxygen atom, and you also have the same link in structure C. But in structure C, you can see that the functional groups are different, indicated by the different colors, and so that means B is the answer because it has the same functional groups or the same monomers. Pterylene, part 4 is pterylene. Okay, so this part C, heck, C is the pterylene. Part 5, a complex carbohydrate, which is A, indicated by the glycosidic bond over here. And that's it. Thank you for watching.